Okay, hello, welcome to another GCSE Design Technology Theory video. This is 5c.4, which is going to be forming metals. Your objectives today are to know what stock forms metals are available in, be aware of the different methods of heat treating metals and why they're used, understand the ways to commercially work with metal. Your success criteria are going to be grades 1, 2 and 3, be able to identify the different types of metal stock forms. 4, 5 and 6, you'll also be able to describe a method of treating steel to make it less brittle and tough enough to work with. 7, 8 and 9, you'll be able to also explain how to create a metal-based product using the appropriate tools and materials and equipment. So, stock forms of metal. This is how you're going to buy the metal in. This is quite important to know. You can buy it in a solid bar, which could be flat, it could be square, it could be hex, you could have it rectangular, or it could be round. And these are going to be solid metal bars, which means they are going to be quite weighty. If you're wanting something a little bit more lightweight and available in a larger section size, then you might want to choose the tube section or the box section, with them being hollow. They're bought in various sort of formats. You can have them as square, you can have them as rectangular box, you can have it as round, or you can have it as oval. And it's bought bearing in mind the thickness of the wall material. A threaded bar is exactly as it sounds. It's a metal bar that's had a screw thread applied to it to enable you to screw a nut on. Metal plate or metal sheeting is going to be quite weighty depending on the size. It is a solid piece of metal. Some of the thinner stuff can also be made into checker plate, and checker plate has had an embossed feature applied to it to apply a little bit of grip. Generally speaking, this will be galvanised at the end. Angle iron and the RSJs or the I-beams, these are going to be more used in the construction industry. Okay, they're going to be load bearing. The annealing process is something whereby if you're working with metals, bending, planishing, rolling them, it's going to stress the material, makes it less malleable, makes it a lot more brittle. And this is a natural process and it's called work hardening. So work hardening you don't want. So you'll have to anneal the metal to make it more easy to work with. So the annealing process is going to be one where it's going to increase the ductility and reduce the hardness of the material again. It involves heating the metal up to a specific temperature, and that's material dependent, and then you allow it to cool down. The process can be repeated multiple times, as whenever it work hardens, then you can anneal it again afterwards. Sometimes though, you do want a product to become harder. So some products require the metal to be harder to perform their jobs better. This involves heating the metal up to a specific temperature for a predetermined length of time, and then you cool it down by quenching it rapidly in either water or in oil. The hardness is going to increase, but it's also going to make the metal a lot more brittle and susceptible to breaking. Tempering is a process that makes the steel tougher and less brittle. The workpiece is reheated again and it's left to air cool, which is going to temper it. It's very similar to the annealing process, but it's going to happen to a much lower temperature, and therefore the cooling is a lot faster. Now, the blade that you can see on there, the knife, there's a part of the blade that you're going to want to be hard. You're going to want it to keep the edge of the blade as long as possible. So this is going to require the hardening process to be done to it. However, you don't want the whole of the blade to be brittle so that it breaks. You're going to then also probably apply the tempering process to that part of the blade to give it that bit of toughness so that you can use it for a lot longer. Things like metals for hand tools, you need to consider that they need to be suitable for heavy use, be hard wearing, tough, and have got good tensile and compressive strength. So remember, tensile strength is when you're trying to pull something apart. Compressive is obviously when you're going to be trying to compress it in on itself. Now, something like a file and a hammer, you're going to require those things to be quite hard. But if you drop them, you might find out that they are quite brittle. A spanner, on the other hand, getting dropped on a fairly regular basis in my workshop, you need that one to be a lot tougher to be able to withstand that, as well as not wearing down while you're using it. Now, different processes. This one's casting, in particular sand casting. The first image on the top right shows a mould being covered in sand, and then the sand's then compacted around it. It's not going to be ordinary sand, it's going to have a binding liquid applied to it, which means that it's going to stick together a little bit more. Once that's happened, then you can split the two moulds apart. Take out your original mould, and then you replace the two moulds and put them back together. You've got a pouring hole and a rising hole. Pour the liquid metal in, oxygen, and then the metal is going to rise up from the other side, and you'll be able to see when the moulds fall. Last image shows the two parts being taken apart, and then you can remove your metal from the actual mould and you've got your casting complete. Commercial casting, very similar to what we do in a workshop environment. This is going to be on a larger scale. Things like car engine blocks and red post boxes in the UK, they're still made in this way. Turning metal, this is when you're going to put it into a centre lathe and you're going to remove your metal around a cylindrical object. You can see a doorknob being created there. Metal's inserted into the chuck jaws and then it's spun around. And you're going to be using various tool bits to create the shapes. So you've got right-handed and left-handed turning bits. You've got one which is going to cut all the way through, so when it gets to the halfway point, it'll separate it. Left hand, right-handed facing tools, and one that'll even create a screw thread. Pressing. This is when a tool is pressed into the metal to do various jobs. It could be blanking, which basically means cutting a shape out. So cutting out a fairly intricate shape, and a bit like a biscuit cutter would. Punching, this will be creating holes and cutting all the way through, maybe to have a bolt or a screw applied through it. Bending, you can see the example of that on the two animations. Drawing, this could be if you're creating maybe something like a dog bowl. And then bossing, we mentioned that before when we're talking about things like checker plating. CNC cutting, this is when a machine is going to be used to cut accurately through the sheet metal. It's probably either going to be a laser cutter or it's going to be a plasma cutting system. And the design or patterns created via CAD and then sent to the machine as a program. The machine then uses computer numerical control to create the design in the most efficient way possible. It could be part of a standalone process, cutting out one part at a time, or it could be part of a production line. Now, bearing in mind, plasma cutting and laser cutting use a lot of heat. That might distort and warp the metal. So this is where water jet cutting comes in. It's a cool process. It's going to be able to cut through metal because it uses a high pressure jet of water fired out of a very small nozzle, and it's got enough power to cut through metals. Normally you'd apply something like a fine abrasive grit with things like stone or glass or metal dust in there, just to create a little bit more in terms of friction cutting through. The process is used when obviously high temperatures from the other methods aren't going to work for whatever you're cutting out. CNC milling, this is a bit similar to a drill bit with a flat bottom, which is going to be spinning, and you'll be then pushing it across the metal to remove certain elements of it and cut it out. CNC, again, controlled. This is going to be used to mill out parts more accurately than by hand. It works on the X, the Y and the Z axis, meaning that it can go forwards and backwards, it can go left and right, and it can go up and down. CNC machines, remember, they will provide improved accuracy and intricacy in whatever you're cutting. They're going to have versatility in terms of the programming and high speed, and obviously increased safety. Okay, thanks.